This video was brought to you by Indently.io, learning Python made simple. How's it going, everyone? In today's video, we're going to be covering 10 of the most common noob mistakes that beginners make in Python, starting with number 1, which is confusing is equals to with is. So to explain the difference, I'm going to create two variables of type string, which are both going to be equal to Bob. And for the first example, I'm going to print the ID of each one of these. So the ID of variable A and the ID of variable B. And then I'm going to use both of the operations. So the is equals to operation and the is operation. And when we run this, as always, we get nothing because I'm running the wrong script. But when we run it again, you'll see that we're going to get true for both of them. And this is usually what makes it so misleading for beginners, because both of these are two completely different operations. And to be more precise, is equals to is only used for comparing the values of a variable, while is used for comparing the IDs. With some integers and some strings and some other values, if those are small enough, Python's going to do some behind-the-scene magic to save on resources and give them both the same ID. Since these are both Bob, there's no point in creating another Bob ID, which means they're both pointing to the same memory address. But now watch what happens if we were to lower this variable. The next time we run this, you're going to notice that we're going to have two different IDs, which means the is equals to check is going to return true because they contain the same value, but the is check is going to return false because these are not the same object. Variable A and variable B are two different things. And I can't tell you exactly what Python uses to determine whether it's going to save on resources or not, but as you can see, sometimes it's going to just create a new variable instead of saving on resources. And the same thing applies to numbers. So we might have 100 and 100, and of course we'll change both of these to integers. These are two different objects which should have two different IDs, but since the number is small, Python's going to try to use some of its magic to save on resources, giving them both the same ID. But these two variables having the exact same ID is never going to be guaranteed. So using is to check the value is just blatantly wrong. Always use is equals to check the value of both of these. And if you want to check that two objects are the same, then use is. I mean, you might have an example where var B points to var A, which means these two are going to have the same ID. And if we were to run it, you'll see we'll get true once again. At any point, if the value changes to 50 and var B changes to 100, we're going to get false for both of them, because now they both contain different values and different IDs, which means they don't have the same value and they don't have the same ID. Moving on to the second mistake, modifying a list while you're iterating through it. And for this example, we're not going to use the old example, but we're going to use something new, which is a list of string. And it just contains some letters from A to E. Now what I'm going to do with this list is loop through it. So for item in items, we're going to check whether item is equal to B, and if it is, we're going to remove it during the iteration. Otherwise, we're just going to print that item. Of course, your for loops are probably going to be much more sophisticated than this, but this is just to demonstrate that things can go wrong if you try to modify your list while you're iterating through it. The rule of thumb is to never do anything to this while you're iterating through it, because it will give you some very interesting side effects. And in this case, when we run it, you'll see that we'll get A, D, and E as an output. We won't get B because of course we removed it, but as a side effect, we also lost C. What happened to C? Well, by removing B, we kind of tricked Python in terms of which iteration we actually were on. So first it looped through A, everything was fine, that's the first iteration. Then we looped through B, which is now on the second iteration, and we removed B. So in terms of Python, we already did the second iteration, which means C is now considered to be part of the second iteration. So we move on directly to D. And as you can see, that's a side effect we do not want. It's unintended behavior, which came from modifying the list while we were iterating through it. If you ever need to modify a list while you are iterating through it, I absolutely recommend that you just create a whole new list. And your logic will change a bit depending on what you are doing. But in this case, I'm looping once again through each one of the items, and if the item is equal to B, we're just going to skip that iteration. Otherwise, we will print the item and we will append that item to the new list. And of course, you're going to have to remember to push those changes to the original list if that's what you want. But never modify the original list while you are looping through it. Noob mistake number 3. By now, you probably know that strings are immutable, which means that anytime you want to modify a string, you're going to have to create a whole new object, which isn't really a problem if you're doing it once or twice. But if you have to do that millions of times in a for loop, for example, then it can be quite costly in terms of performance. So I'm going to be showing you an alternative that you can use that can optimize your code in certain situations. And in this case, we're going to have these two functions, and they both perform the same task. For the first one, we create a text object, which is initially empty, and then we have a for loop that loops 50 times. And during each iteration, we add text to text. So this is going to be a long string that just says text, 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 text 50 times. And then we return it. And as I mentioned, since strings are immutable, here we're not adding anything to the text. We're actually just creating a new string with the new text each and every single time. And that can be quite costly. I mean, if you're doing this 50 times, probably doesn't matter, but once you start getting into the millions, then it does start to matter. And for the second function, I start off by creating a list of string, which is initially empty, and then I use the same for loop. Except here I append text to the list each time we iterate through it. And instead of creating a new string object on each iteration, I just perform one operation at the end that joins all of these elements and gives us back the exact same result. Now to test this, I'm going to create my if name is equal to main check. And of course, the very first thing I want to do is check if they have the exact same result. So if append text returns the same thing as text join, that means we're good. That means we can actually test this code. So let's run that real quick. And what we should see is that they both give us back the same result. And for those of you who are curious, the result is going to look like this. Text, 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 text 50 times. Now to time the code, I'm first going to provide a warm-up for the interpreter, and then I'm going to time both of them using the timeIt module, which by default runs this function 1 million times. And then I'm going to use this sweet sugar syntax with f strings to print the result. And I only care about the first 5 decimal places. So here we have the normal for loop where we just keep on creating those text objects or those string objects. And then here we have the join method, which just joins it all at the end. And if we were to run this, first we'll get that the same result is true, which is very important, but then we'll get the time it took for the normal implementation and the join implementation. And as you can see, the join was much faster in this case. We saved 1/3 of a second by using join instead of creating a new string object on each iteration. And once again, that's because creating a new string object on each iteration is a costly operation. So that's just something to keep in mind when you are working with immutable objects. Noob mistake number 4. Overcomplicating file handling. Suppose you want to open some sort of file, which in this example is going to be a text file. Well, one way to do this, and this is something you'll see in a lot of beginner tutorials on the internet because they're kind of outdated, but one way to do this is to just directly create a file, which will be of text in out, and just open it. Although in the online tutorials, you will probably not have that type annotation. Anyway, what we want to do with this file is read the content and print the content. So here we're going to read that content, which is going to be of type string, and we're going to print it. And finally, we need to remember to close it. Otherwise, that can lead to memory leaks. And right now, if we were to run this, it runs perfectly fine. We get the content of the file. Although there are a lot of problems with what we did here. One of them being, if we have any errors that occur between the opening and the closing of the file will never close properly, which once again will lead to memory leaks. Second, we are human, and the chances of us forgetting to close the file might be small, but are not zero. And we don't get any warning for that, which means we can easily create an entire program without ever closing any of the files that we opened, which is actually very silly. So of course, one approach might be to wrap this all in a try and except block, except in this case, I just used try and finally to keep it short, so that here we open the file, we try to get the content, or we try to perform some sort of operation with that file, and if it goes wrong, we just close the file. And this will ensure that it closes no matter what. So yes, that's one alternative. But there's an even better way of doing all of this, and it's much more safe and much more convenient. And what I'm talking about is using the with keyword, which creates a context manager for us. So here we type in with open notes.txt as file, and then we just read the content the same way as from earlier. And then we can print that content. And the benefit of this approach is that it saves us the trouble from using the try and except block. Or that's not entirely true, but it handles closing the file automatically for us in case anything goes wrong inside the with block. We don't have to remember that small detail at any point. And if you're watching this in 2024, this just feels much more Pythonic. It's shorter, it's straight to the point, and gives us all the same functionality. And you're probably wondering about these red squiggly lines. Well, that's because MyPy is really angry that I redeclared content, so if we just remove that, the red squiggly lines go away. But now, if we were to run this, we would get the exact same output. Of course, it's a good idea to pair this with the try and except block in case you have any errors. But again, it's just a much more Pythonic approach to dealing with files in 2024. So I absolutely recommend you use this approach whenever possible. Noob mistake number 5. For this example, I'm going to introduce two variables, one that's called name and one that's called number. Now suppose you want to compare the types to see whether they are the same. Well, the first thing you might think of is using the type keyword or the type method to check the type of each one of these and compare them using the equality operator. Well, while this actually does work, it's not recommended, and PEP highly discourages it. I mean, right now the types are not the same, but if we were to have a new variable of type string, and we're just going to call that x, and we were to put that where the number is, you would see that this would return true because they are both of type string. So what's the problem with doing this? Well, for one, it's not that readable. And second, this is far too strict for comparing types, especially when it comes down to inheritance. But I'm going to be showing you that in just a moment. So what's a better alternative? Well, in Python, we have something called isInstance, which performs the exact same operation or something very similar. And this is much better because it's much more flexible. And there's also much more we can do with it. So right now we're using isInstance to check that name is of type string, and isInstance to check that number is of type integer. If we were to run that, we'd get true for both of them. At any point, if one of these were different, we can say that's of int, and this can be of type tuple, not with a y, you'll see that both of them will return false. So this can be considered much more readable. But another benefit is that we can also paste in multiple types. So we can check that name is of either string or integer, or that the number is of type string or integer. And both of those are going to return true. But as I mentioned earlier, it also works very nicely with inheritance, which is very important. Because with isInstance, we can check that a cat object is of type animal, which in this case it should be, and that means we will get true as a return. While if we use the other ugly syntax, which checks the type of the cat object and compares it to the type of animal, which could also just be animal, you'll notice that we're going to get false, because these are two completely separate types, and we can actually print both of them. We can say type of cat and type of animal. And that's actually my bad. Animal should have some parentheses. And you'll see that these are both going to be considered two separate types. What it's comparing is not what we wanted to compare, because a cat is an animal and is guaranteed to have those methods. So it can be considered an animal. And type is just far too strict. I mean, a cat is not exactly an animal, but it is a type of animal. And that's why it's good to use isInstance in that case, because it works with subclasses, which in most cases will be what you want. And isInstance is still strict enough to know which order things should go in. So an animal is not a type of cat. It does not work the other way around, because a cat might have some special qualities that an animal doesn't, which is quite generic. And that will obviously return false. A cat will have all the qualities of an animal, but an animal will not have all the qualities of a cat. Moving on to noob mistake number 6. Here we're going to have some letters, which is going to be of type string. And what we want to do is enumerate these letters. So here what we're going to do is type in for I and letter in enumerate letters, we're going to print this f string, which adds 1 to each iteration so that the list starts at 1 and then provides the letter. So what we're going to get as an output is this very nicely formatted list. But what a lot of people don't know is that this operation is completely unnecessary. So what we can do instead is remove the +1, and inside enumerate, we can just add 1 there, which provides the start of the enumeration. And this can be literally any number you want. But by doing this, we don't have to perform that silly operation on each iteration, and we will get the exact same result. Some devs are going to claim this to be quite illegible, so something you can do to warm their hearts is add the keyword of start, so they get a better idea of what it is. And as I mentioned earlier, this can be literally any number. You can even start it at -3, and it will start the enumeration from that point onwards. Otherwise, you would have to think about the math here, so you can do, I don't know, -4 or -3, because it starts at 0. I'm already a bit confused, but I think it's something like that. Yeah, and then you would get the same result. So it practically just saves you the trouble of doing that random operation here. Noob mistake number 7. When you're writing code, it's going to be quite common to have lists somewhere in your code. And sometimes you're going to want to create a copy of that list. But unfortunately, what a lot of beginners think they can do is literally say that B is equal to A. And unfortunately, this doesn't copy anything. It just creates a reference to the original list. And in other words, it practically means we just created an alias for A. So B and A both point to the exact same list. And we can actually verify that by printing the IDs of both of these. You'll see that these are exactly the same. And that also means that if we were to modify these lists, both of them are going to modify the exact same list. And we can demonstrate that by printing both A and B. As you can see, first we added 111 to list A, and then we added 222 to list B. But since they both pointed to the exact same list in memory, it updated both of them. Moving on to noob mistake number 8, which coincidentally will also show you the solution to noob mistake number 7. So once again, we're going to have a list, which in this case is going to be of type any, because it can literally contain anything. But what this list will contain is an integer and a list of string. So it contains a reference type. Now, suppose we want to create a copy. Well, we learned in the previous noob mistake that we can't just use the equals. We're actually going to have to use a special built-in method to successfully copy this list. So here I'm going to create B, which is a list of type any as well, and I'm going to use the built-in copy method. Now we can actually do something cool, such as b.append, let's say 10, and when we print the results, you'll see that B did not affect A. So we've successfully created a copy. But now comes in noob mistake number 8, because we did not really create a true copy of list A, or we didn't really create a deep copy of list A, which means that if we were to edit something inside the reference type, such as B at the index of 1 at the index of 0, which would refer to A over here, and we were to say that's equal to changed, what you're going to notice is that that's going to update both of the lists, because this reference type still occupies a single spot in memory. So unfortunately, a lot of beginners use a.copy thinking that everything was deep copied, when in fact it wasn't. If you actually want a deep copy, you're going to have to import deep copy from the copy module. And then you're going to have to type in deep copy and pass in what you want to copy, so that the next time you actually try to change a reference type inside the original, it won't affect both of those, because now this has its very own spot in memory. So why isn't deep copy the default implementation? Well, performing a deep copy is actually quite expensive because it has to make everything inside the list unique. And that can be very costly. So by default, Python chose to use the optimized approach, which should be good in most scenarios, which is just creating what is known as a shallow copy, which copies everything with the exception of the reference types. So it's just one of those things you need to know in Python when you are working with your data. Noob mistake number 9, poor exception handling. One thing you'll see a lot of beginners do, or people who don't care about their code do, is create the most generic exceptions, or try to handle everything in a single exception. For example, we might have a function called readFile, which takes a path, and inside there we want to try to read that file. So of course we're going to use that sweet sugar syntax or the with keyword to open that path in read mode as a file, and we want to read the contents and return it. If it's empty, it's going to obviously return none, so we're returning a union type. And if anything goes wrong, we're just going to print lol and also the error. So this is something a lot of noobs do, which in my opinion, if you're creating a serious program, is completely unacceptable and just tells me as a developer that you know absolutely nothing about your function and what can possibly go wrong. It's like a wild card. You don't know what's going to happen, but if it happens, you're just going to print some sort of message. So this is one practice I absolutely recommend you avoid. Show that you know something in programming. Show that you understand what can possibly go wrong with the code. Add the exceptions that actually matter, such as a file not found error. This is specific. This is something that actually can go wrong in this try and except block. And here we're actually handling it the way we need to handle it. I mean, using a print message is also a noob mistake. You should use some sort of logging, but for this video, I'm just going to be using this print message as an example. Whatever you do to handle that is up to you, but show that you know that that's what can possibly go wrong with your function and handle it properly. But on the other hand, if you're creating a script very quick and dirty, this might be the perfect place to handle it because it's easy. You don't really care about what goes wrong, you just care that your program doesn't crash. But to continue with this example, something I might do with this exception at the bottom is just say that a new error was encountered. And in production, you might prefer that to your app actually crashing. But in development, the more exceptions you encounter, the better, because that's what's going to build a robust program. You knowing exactly everything that can happen will show your strength as a developer. Seeing someone do this in the code always makes me laugh, unless it's a throwaway script, which means you're just running it once because you want your script to perform one very specific and personal task. Then I don't even see the purpose of handling the exception. But for me, seeing everything that can possibly go wrong is a really strong sign that the developer cares about their code and knows exactly what they're doing. And finally, one of the worst habits you can develop, or one of the worst noob mistakes you can develop is giving your variables and functions names that are impossible to remember the next day. For example, here I'm going to create two variables, one called Q and one called T. Q stands for questions and T stands for text. Without these comments, I can guarantee you that neither I, nor you, nor anybody who comes back to this is going to understand what Q and T is the next day, especially without comments. I mean, look what happens when I remove that. This immediately becomes impossible to understand. I mean, a lot of people will think T stands for text, but in this case, T stands for terrible. Don't do this. What you should be doing instead is giving all of your objects meaningful names, such as questions or text. And even text can be improved because text is quite a generic name, but it's still much better than what we did here. And it's good to keep them short and concise, just enough to get the point across. Otherwise, I really don't recommend you do something like this either. The intro text that the user sees. Sure, this is quite descriptive, but I'm not reading all of that. So in that case, I would just type in intro text. And if you really want to be specific, maybe it's for the screen, you can type in intro screen text. Whatever gets the minimum point across without creating any confusion. But yeah, those were 10 of the most common noob mistakes that I've encountered throughout the years, or at least 10 of the most serious ones. There's a lot of other noob mistakes that you'll see around on the internet. Some people still use semicolons. Some people really like to use code golf on their professional code base, which makes it unmanageable and illegible for any non-robot. So there are still a lot of other noob mistakes out there. I would love to hear if you have any that you've encountered. Please leave that in the comment section down below. A lot of you don't know this, but I do actually read every single one of them, with the exception of the ones that are filtered out by the automated spam system, but I do read each and every single comment. But yeah, with all that being said, as always, thanks for watching and I'll see you in the next video.